Hey guys, welcome back to the channel. This is going to be probably part 3 of this Terex 85 Manlift that I bought for cheap. And my problem I'm going to work on today, well, we'll see. Problem is, the controls here from the basket don't all work correctly. I can start the machine from the basket, and when I use the dead man's foot switch there, I can actually make the unit drive forward and backward. However, I have very, very slow, if barely any response at all from this joystick when I swivel it. And raising and lowering, it does do it, but it seems slower than it does from the controls on the side of the machine. And when I first got it, it didn't seem to want to go down at all. So that was kind of disconcerting because nobody wants to be stuck 85 feet up in the air. And then this control here, which is to extend and retract the boom, does not do anything at all. Yet the boom does retract and extend from the controls on the base. So that makes me think that that is something that's localized to that switch alone, which is what I'm going to go after first, because I think that's going to be something that's going to be something I can handle diagnosing and figuring out whether or not that switch is good. But what I want to do is I want to take this whole unit out and bring it back to the shop so I can put it on my workbench and work on it in comfort with better light. And then while I'm in there, I can just look at the general conditions, see if water's gotten in there and is causing any other kind of problems. These holes here almost make me think there's supposed to be screws that are missing. It almost looks like, I don't know what somebody did here. We got like a lanyard wrapped around this whole thing. Oh yeah, so for crying out loud. Yikes. That's a mess. Okay, so I really don't want to do that, because I know that right now there's 12 volts coming up to this thing. And I know that because, oh no, actually with the switch off down there, there is no 12 volts coming to this switch. This is also messed up here. This needs some attention. It's very loose. Okay. So what I'd like to do is try and take this whole box off and bring it back to the shop, because even though I could take this top piece with me, I can't disconnect this from the bottom because there's a bunch of relays, PC board, there's all kinds of stuff going on inside here. So there's one large plug that goes into the bottom of this, and I'm willing to bet that if I take the right screws out on the bottom here, that this plug is designed to be able to be unplugged from the whole thing. Alright, so take the 4 nuts and lock washers and flat washers off the bottom of these studs, and this whole unit can come off of here. There's all kinds of debris falling out of here that makes me think Mies is in the house. And this electrolytic capacitor just fell out of here. And yeah, there are no leads on it. So this probably came off of the PC board. Now if I open it up and there isn't a new one on there, which I kind of doubt. I mean, why would you leave this? Why would you break this off the board and then just put a new one in and leave this in there? This is actually good news. This is something I can fix relatively easily, and I wonder whether or not that would make everything start working. Wouldn't that be awesome? But anyways, I got to get this off of here. So the next problem is, again, this one big plug, and the way this works is right in the center of this big plug. It's kind of hard to see, but there's actually a hex head cap screw right there. So I got to get the right size Allen wrench and unscrew that, and that will allow this to unplug from here, and then I can take this whole box inside just in time because it's getting dark. All right, I got the plug out. Like I said, there's an Allen screw right here, and the contacts look like they're in great shape. They're not all corroded, so that's a good sign. For the most part, the wiring looks, well, no. You know, we got corrosion and missing insulation on this wire right here. And we've got, this wire's got a nasty kink in it. Now, might have to address that. Again, all of this stuff fell out of the box when I turned it on its side. So that would indicate to me some sort of insect or mouse activity, I guess. Interesting to me, we got a couple of wires right here that are just floating, not going to anything, but I'm noticing there's another capacitor right here. So it looks like what they did is they just ran wires to these capacitors and then zip tied them to these little adhesive pads which have broken free. Well, you know what? There's no reason why we have to do this out here. Let's get this under some better light in the workbench. Alright guys, so here's the inside of the control box for the basket, the upper assembly there on the Manlift. And when I opened it up, at first when I opened it up and I saw a lot of these wires that I'm going to show you in a minute, I was kind of like, oh boy, how am I going to figure out where these wires go to kind of see if I can fix this thing. And I was a little concerned, but then I noticed as I separated it completely, there's one large wiring loom assembly here that's tied together. This assembly right here that connects everything from the bottom to the top. So when I move this apart, I realized that the wires I'm going to show you that I found disconnected on this upper assembly that I'm wondering about, I don't have to worry about them connecting to anything down here, because I think this is completely isolated from here by this wiring loom. If you get my drift. So let's start by just looking at down here. Alright, so the first thing I noticed was that there was debris inside here, and upon closer inspection I am now pretty confident that this is very, very dried sawdust from chainsaw work. So I think they were using this machine for tree work, and that's how this stuff got in here. The good news about that is it's not what I had feared, which was that rodents had gotten in here and brought that debris in. So I don't have to worry about mouse urine being an issue of causing some severe damage here. There is some clues about some things, like for instance this piece of black electrical tape. I'll show you in a moment where I think that came from and why that shouldn't be in here. We have a wire that is just hanging loose here and another wire that is hanging loose here. Those are the only two wires I can find in the lower section that don't appear to be connected to anything, and as you recall, a large capacitor fell out of this unit. Well, there's one of the two large capacitors that was in here, and the other one is the one that fell out. So I feel fairly confident that these two wires went to that capacitor. Now, that being said, remember when I found the capacitor fell out, I got kind of excited because I was hoping that the capacitor was like on this circuit board, for instance, and that by that capacitor having broken free, that it was causing some sort of weird electrical phenomenon that was causing the thing to malfunction. Well, it turns out these capacitors, the one that's missing and this one, are across these two devices here, which are the alarms. So that alarm that's beeping like crazy to tell you when things aren't going right, there's one here that beeps for some reason, and here's another one that beeps for some other reason. That's all those capacitors do, is they're across those alarms. So I'm going to replace it because obviously there is a purpose to them, but just so we know that this isn't going to, replacing this capacitor is not going to resolve my issue. You can actually see that this wire and this wire go right to this plug and go right to this alarm. And then this one right here has these two wires. They're a little harder to see, but they run right over behind here to the connections on this alarm. So that's pretty straightforward. Not going to worry about that. As far as the polarity goes, that's pretty simple also, because in the manual
I did notice that they tell you that unless otherwise specified, the yellow wires with the green stripes on them are grounds. So that's going to be the negative on the, because these are electrolytic capacitors. They have a polarity to them, and you can't put them in backwards. So this will be the negative terminal will go here, and the positive terminal will go here. The capacitors themselves are actually, the way that they indicate polarity on it is this white band right here. So you get this white band with a dash mark. That's a negative sign. That's telling you that the lead that's closest to this side, which is this lead right here, is negative. And you'll notice that if I carefully move this out, you can see that that is the yellow wire with the green stripe is attached to that one. I'm going to clean out all this debris that's in here, and I'm also going to probably pull out this circuit board, just kind of get a good look at it. I want to see if there's any corrosion or anything on that board that looks like it might need to be addressed, and clean it up. If I see any obvious bad solder connections, I'll probably reflow those, but I don't want to do too much as far as monkeying around with that board. This is the back side of the large plug that goes to the cable harness that runs down to the base of the machine. But I think by design that the controls up on the top here, this upper unit, these controls send all of their signals to this board, and then this board will send a signal down to the base. The reason why I say that is because I think they call this board a transmitter board, and I think there's a receiver board in the base. This whole control box appears to be made by a company called OEM Controls, Inc. of Shelton, Connecticut. I don't know if they're still in business or not. Even this board right here is an OEM Controls, Inc. board. It's an SB10 Superflex. All right, I just did a little bit more Googling and found out that this OEM Controls, Inc. company is still in business. Apparently, they don't work on these anymore, but they are willing to, if you want to send in your boards, they'll test the boards and tell you if the boards are good or not. And then somebody in a forum said, you know, they sent in their SB10 and the company told them that the board was good, working, but they recommend upgrading it to the SB10X. And then the two other boards they sent in, I guess from the base control box, ended up being defective is what they were told. So the recommended solution was to replace all three boards, and all three boards, they were quoted around $6,000. Now, you can see what is going on here with these PC boards. There's just not that much going on here. There's no reason on God's green earth that they should be hosing anyone that kind of money for these boards, but that's industrial controllers for you, I guess. They figure because the companies that are buying this kind of equipment must have deep pockets. I don't know. I don't understand the economies of it, but it's always been that way. The more I read about this, the scarier it seems to get for me. I keep reading in forums that apparently these controllers were very problematic, and a lot of guys seem to be reporting the same problem I'm having, where it sometimes works and it sometimes doesn't. The problem with these things, obviously, is you can't have the thing decide to stop working for you when you're 80 feet in the air. So interestingly enough, one of the guys on one of the forums said what he did in his case was he decided to convert his entire machine over to a Genie controller. So Genie is a lift company. I don't know if they're associated with Terex now or not, but the Genie lifts, apparently their controllers are much more reliable. So his thinking was he was going to basically figure out a way to make the Genie controller work on his lift. Another option from one of the guys who was having trouble, he ended up finding a company called Hindley Electronics, which is also still in business. And Hindley Electronics was able to furnish him with a board to replace one of his bad boards for a lot less money. So that's kind of interesting that they were able to find something that would do the job. I don't know how much he had to modify his system to make that work or not, But I just went to the Hindley website, and they actually show that they have controllers, like almost like generic controllers that they have available that you can buy for these machines. I don't know if they have one in particular for this specific model, but I wouldn't be surprised if they did. Now that's interesting. I just pulled this screw from out of the sawdust right here. Now the good news is, even if it had gotten underneath here, it wouldn't have touched the underside of the circuit board, because this is a metal plate and the board is sitting on standoffs on top of the metal plate. So even if like water got in here, it would have to rise to quite a level. And there's actually, I think, drain holes in here. So, well, anyways, that screw shouldn't be in there. So let's take a look at this upper section here, and I'll show you some of the things I spotted that aren't too kosher. Alrighty, so right here are 3 wires that are tied together. They're just twisted together and just left hanging open here. So that could easily short up against something and cause a problem. So that's not good. That's where I suspect the electrical tape was. I think somebody just tied these together, put the electrical tape around it, and the tape fell off. So definitely going to have to A, make sure these wires are going where they're supposed to go, and then B, put a better connector on there. Here are a couple of wires that have these little crimp-on terminators on them. So I don't know whether or not they're just used for something else, because there are a number of options that these machines could have that this machine might not have. But then there's stuff like this, okay? So this is that, this goes to this, and this goes nowhere right now. So I'm not sure about that. While I'm in here, I definitely want to fix this switch. This is the ignition start switch here. Wondering why that was so loose. Well, it's because the screws have fallen out of it. Here's something interesting to me. We've got a connector, so I can pull this out, I'm pretty sure. Right? So why would you have that spade connector going to nothing plugged in to here? I mean, if this was for an accessory that's not being used, then why the hell wouldn't this just leave that hanging like that? Instead, they got this. And then here's one that's been shrink wrapped at the factory. This over here is the unit for driving and steering, and that looks relatively unmolested, so I think maybe I'm going to steer clear of messing with that at all. This is the boom extend, boom retract switch assembly right here. So I noticed this wire right here is damaged, and this wire right here has this tape on it right here. I'm not sure if that's covering up any damaged insulation or not. So these 2 little wires here, the red and the black ones, they go to a box down here, which I haven't been able to identify what it is yet. So let's start with what I thought I was going to find on this unit. Remember, this unit does retract and extend, and it also is a proportional unit. In other words, the further you push the joystick towards one direction, the faster it'll extend out, and the further you pull it back, the faster it will retract. So it's not just an on-off type switch situation here. There's got to be something to tell the system how fast you want it to move, in which direction you want it to move. So what I expected to find was, I expected to find a potentiometer, which would give an electrical resistance to the board down here, the aforementioned board, and the board would interpret that signal and send data down to the other board in the base to tell the unit what to do. And then I expected there to be 2 switches, one to tell it that you're trying to move to extend the boom out, and one to try and tell the system that you're trying to retract the boom. So what I found instead is there's only one micro switch on this thing, and there's only 2 wires. So it's not a situation where like the switch has dual contacts in it or something. So that's kind of a bummer, because what that tells me is that when this switch closes, this is not what tells the system that you want to retract or extend. All this does is tells the system you want to do one of those 2 things. Meaning this can't be a regular old potentiometer that just gives you electrical resistance. This has something else going on. And I'm wondering whether or not, because it has a black and a red wire going to it, if there isn't something in there that actually has a polarity to it in addition to maybe electrical resistance. So this is a special animal, which stinks for me, because whenever you get into, this is not something I'm going to be able to like go and look in the DigiKey catalog and find a simple part to replace this if this is bad. Not only that, but if I can't identify what it is, I wouldn't even be able to measure it to tell you whether or not the proper signals are coming out of the damn thing.
It seems to me like originally these wires probably were anchored in a way so that they couldn't accidentally get pinched in this gear, because what's underneath here is there's a sector gear, and when I move the lever, that's rotating a shaft, which is rotating this electrical device, the mystery device I was talking about. So the switch and whatever signal comes from this electrical device all ends up going out on 2 connections. That's it, right here. This is not used. So go figure. And of course, the other problem I'm having with this unit is that the other joystick control, the proportional control, when I do activate it, if it works at all, it's moving much too slowly. It doesn't seem to be getting that signal telling it I want to move faster. So imagine taking this and putting 2 of them into one unit. And if you can wrap your head around that, that's essentially what they did here to make this joystick controller. So this is the joystick controller that swivels the machine and raises and lowers the machine. And this has got some more funky stuff going on here. Again, I see tape that doesn't look quite kosher to me. And if that tape isn't kosher, this tape is certainly not kosher. And then this wire is practically completely broken. But it's not. I'm going to do a continuity check on that. And then those wires come down here, and this is what really caught my eye and is sketchy as hell. So this gray block right here is one of the 2 mystery devices that I was talking about that would act to give you the proportional part of the equation. Well, look at the 2 wires going into it right here. They are completely devoid of insulation, and the 2 wires are right next to each other, and they may have very well been touching. I'm not positive. So yeah, that's on this one, which is the moving the stick forward backwards, which is boom, lower, and raise control. This gray block back here, is for the swing. So these 2 wires are going to that, and one of these wires looks damaged also. And if we look at this terminal strip, it appears that just like the other joystick, you really only have 2 connections to do both the initiation and the proportional part of the equation here. There's 4 wires because this is 2 of those in one assembly. Okay, so I disconnected 1 wire to this, which basically takes this out of circuit, and I want to see whether or not I can measure any kind of resistance between here and here. So the circuit is pretty simple. It appears like the switch is in series with this device down here. This device, by the way, I was able to find out that OEM Controls apparently refers to this as a digi sensor. So I still don't know exactly what it is. I don't know if it's a simple potentiometer or if it's something more. I did find out that you can buy replacements of these. Radwell and some other companies seem to have these, but they're crazy expensive, $200 to $400 for this little piece right here, which is just insane. But you know, what are you gonna do, right? So I've got this set to the 20 megohm range, which is the highest range for resistance. In fact, at that range, it can actually measure the resistance of my body. You can see I'm actually getting a reading by touching here and touching the other probe. So if there is any sort of resistance at all that's measurable between here and here, I should see some kind of a reading on the meter. Now, OL means out of limit. That's infinite resistance, which I would expect to see because I haven't moved the toggle yet. When I move the toggle, the cam will close that micro switch, and then it should put that device, the mystery device, in circuit. All right, that's all the way to one direction, nothing. All the way the other direction, nothing. Okay. So that's interesting. But the first question I would have is, maybe that's normal. Maybe there's something special about this device that I'm not aware of. Let me just, for the heck of it, see if polarity makes a difference. It does not. Polarity might have made a difference if there were diodes internal to this mystery device. All right, well, so we know the drive one seems to be working. So let's see if the forward reverse makes any difference. So again, we're going to the switch. So now I'm on the forward reverse toggle. Let's see what happens when I move this. Oh, nothing. That's unfortunate. And I know that works. So that tells me that by design, apparently, I can't measure what this thing is doing. That stinks. So it looks like the only thing I can really test on this is this micro switch. All right, so that's infinite resistance. Hey, that's a good sign. Oh, that's a good sign. Boy, wouldn't it be nice if the only problem with the extension retraction is that the darn micro switch is bad. That's an easy. Oh, that just broke. Alrighty. Okay. The heck? What is that? Did somebody just jam a piece of wire in there? Look at that. I just pulled that piece of wire out of this slot right here, which is supposed to be where the connection was that broke off. Oh man, that's hilarious. Alrighty, let's get this assembly out of here. All right, removing this assembly was pretty simple. Just 2 screws on the top side and this whole thing drops down. It would be nice if I could get another rubber boot for this thing. This one's torn. That would allow water to get down inside here. That is not what caused the failure of this switch though. Maybe somebody was in here troubleshooting and they went to pull this off and they broke that connector right off. This is a pretty basic micro switch. These switches are designed, they have 3 tabs on them, 3 connections, because they have a normally open position and a normally closed. So there might be a situation where you want to use a normally open contact or another time when you want to use the normally closed. So what they do is they make this the common, and then depending on which one of these tabs you will hook up to, you will get continuity in either the open or closed state of the switch. Because of the way the plug is designed, I can clearly see that there's no wire going to this bottom one. So they're not using this tab right here, which is still good. They were using this tab, which, as I just showed, had been broken off by somebody, and they just stuffed a piece of wire in there, and I guess that was letting them get by for the time being. This one is actually, now that I look at this one's really pretty bad too. So the good news is this, unlike everything else that I've looked up so far, is a very generic standard part. We don't have to go to OEM Controls, the manufacturer of this mess, to get this switch. Matter of fact, I'm going to look. I have quite a few of these micro switches. I might even have one that fits. So there's nothing really special about the electrical part of the switch. These micro switches like this are pretty standardized. What's unique about this one is that it's got this short little lever with this roller on it. So I've got to see if I've got one like that. So the most basic rudimentary form of these version of these switches is this right here, where you just have this little plastic piece that sticks up, and then you have something that would engage this to activate the switch. These are very common in microwave ovens in the door latch mechanism. Oftentimes you'll have multiple ones of these in there for redundancy, all to make sure that no one can start that microwave oven with the door open. And the other version you tend to see is just with this metal leaf on here. Oftentimes when you buy these, they can come with just a straight leaf and you can bend them to suit your application. But I'm looking for one with a roller like this on the end, but that one's too long. But as luck would have it, I have one of that style in stock. This is not a lot of current going through this, even though these switches tend to be rated for pretty high current. Just do a quick continuity check and make sure that this is not a bad switch. All right, we have a good switch. So let's get the right size Phillips screwdriver and we'll change that switch out. All right, got the new switch mounted, so now we can do some continuity tests. So right now I should have continuity between this bottom one and the top one, which I do, and open circuit between these two, which I do. And now when I activate this, I should get continuity. And I do. There's a little bit of oxidation on that connector, I guess. All right, so now we just plug this plug back in. So now I want to see what's going on underneath this Mickey Mouse tape job that I see here. This tape is doing a good job of sticking to itself, but it's not really sticking to the... Oh, there we go. So we've got a damaged wire right there. Yeah, that doesn't look too kosher. So this appears to be a pretty clear part number right here. Guess what happens when I Google that? No problem at all finding a new one. Aftermarket. Intella Parts Company LLC would be happy to sell me one. Yeah, that looks like the right animal. Oh, let's see how much that is. $944.45. That's right, $944.45 for that. For this. Ridiculous. Oh, look, it's 28% off. Isn't that nice? Retail, $1,311.36. Yeah, right. Please. And if you think it's just that one company that's hosing you, no. Well, this is quite a bit better. $565, $792.93. If I want to buy it overseas, I can get it from this company for $364.64, whatever that is. And you can see the part number in the picture here on that device that I can't identify. It's a OEM Controls part number EPVR347. So the Radwell International website calls that device a servo drive / servo control. And they have them for $632.05. That's just for this unit. Yet that other manufacturer will sell us the complete assembly for $700, right? So go figure. So this company called Hindley Electronics Inc. has the best price I was able to find for that particular little device. It's the $222.87. So it's interesting. It even comes with the wiring and the plug to go over to the switch. There are several part numbers here for some reason, so these all might be a little bit different. This number over here on this sticker doesn't seem to cross to anything, so I don't know what that sticker's for, but I'm not worried about it. But this tiny number over here is interesting. It's 98.09.09. So that's probably a date code, meaning September 9th of 1998. This machine is a 1998, so this is the original controller from this machine. Seen a lot of hours, I'm sure. All right, now that I've gotten this all straightened out, got the new micro switch in, fixed this wiring, and soldered the splices together and shrink wrapped them. I'm happy with that. So now I'm going to turn my attention back to this main unit here and some of the funky wiring I'm seeing going on in here. So remember when I opened it up, I saw this mess here. So we got these 3 wires tied together, but one of these 3 wires actually does nothing but go over to 2 more connectors, which may or may not have ever had anything even attached to them. But I'll get to that in a moment. So what I did was I looked at what this wire number is on here, and it's number 32. And the good news is this is also 32 and this is also a 32, so at least these wires are all supposed to be tied together. But the question is, what purpose does all of this serve? So here's my wiring diagram. The problem with the wiring diagrams are that they're from a download PDF file, and when you try and enhance them or enlarge them, the resolution goes away and you can barely make out the numbers on the wires. But I was able to make out enough to figure out that 32 is actually the where the main power comes into the system here on number 302. So wire 302 is right here. It comes from the plug, the main big plug that goes down to the lower unit. And then it comes right over to the circuit breaker. And then on the other side of the circuit breaker is where it turns into 302 turns into wire 32. Wire 32 goes over to something here that I can't quite make out what it is, but it's an option. So it might not even exist on my unit. It also comes down to here, goes over to the E-stop switch, which is that big red button. And then through the E-stop switch, it goes over to the ignition switch. And then it also goes all the way down here. And then it also comes all the way down here and goes over to what is described as an optional platform work light option. Now, the only thing I can figure that they're talking about there is that they're talking about that on some of these units there may be a small light that can light the controls for you if you're working at night. And I don't have that. But the main point to all this is that once that 32 comes off of the circuit breaker, it really only potentially goes to 3 places. And 2 of those 3 places might not even exist on my machine. So here's the circuit breaker, and sure enough, this wire comes off the circuit breaker, and it's labeled 302, and it goes right to the back of the socket for the main plug. So that means this other wire right here should be number 32, and it is. And 32 goes into this larger wiring loom up towards the top. So I was able to determine that this wire right here is number 32, that comes from this main wiring loom going back down there. And it only comes over to here, goes right to this termination, and then has another 32 wire come right out of it. So this would probably be option number 1 connection, which right now it has just this stuck in it, which does not appear to have ever had a wire attached. So I think this is option 1 that I don't have. So then 32 is right here, and it ends up being one of the 3 wires tied together here. So I'm going to disconnect that. This mystery wire that goes to nothing and has 2 connections is also a 32. So it's actually supposed to be in there. But since it goes to nothing, my suspicion is that this was supposed to go to option number 2 that I don't have. But that doesn't quite explain why there's 2 connections here. And they both have number 32s going to them. Well, let's see. So this other 32 wire should go to the last place, which it should go to the e-stop. Oh, well, look at this. So get a load of this. This wire is supposed to go through the e-stop switch before it gets to the ignition switch over here, and instead it's going directly to the ignition switch. So what goes to the e-stop switch? Well, now when I move this wiring harness out of the way so I can see the back of the switch clearly, there's nothing hooked up to it. They've completely bypassed the e-stop switch. And here's the funny thing. I just tested it. It's perfect. It works perfectly fine. So they disabled the e-stop for some reason. Who knows what. So what that means, though, is that that's probably what... Remember that wire I just pulled off that I said, hey, we don't need it? Well, but why does it have 2 plugs? Well, probably because the other one of those 2 plugs was probably supposed to go over to this switch. Okay, so I ran this wire from the ignition switch over to the one side of the e-stop switch, and then from the other side of the e-stop switch I connected the wire that comes from the splice over here off screen that I showed you already. So now the circuit is exactly the way it should be, except it doesn't have a splice for hooking up whatever that mystery option is. So I can just leave this wire out altogether. It's not needed. So I'm wondering why they would bypass the e-stop switch, and the only reason I can think of is that they were just trying to rule out if that was a problem. So maybe they were having a problem and thought, oh, let's bypass the e-stop switch by disconnecting the wires and twisting them together and rule that out as an issue. But I did verify that the switch is working with my ohm meter, and I can't think of a reason why I wouldn't want an e-stop switch, so I wired it back in. This is... I have to figure out why this is so loose and fix this. These wires here obviously go to the switch I took out. So I'm not seeing... Okay, I want to see what's going on here. I don't like this. This might just be a wire that goes to nowhere. I'll have to check. That appears to be number 42. But these wires right here, this shouldn't be like this. So this splice doesn't belong from what I can tell. So let me take a minute with the wiring diagram and see what I can come up with. So 42 goes all the way down to the main plug. So I can't figure out, because it's not on this wiring diagram, can't figure out for the life of me what that is. This wire right here, which also goes to nowhere, is marked 311. But this one I found on the wiring diagram, and it says it goes to the generator option, which means if you had an optional generator to run this thing, or generator power, I guess, I don't know. But I know I don't have that option. But here's something interesting. This wire was kind of resting in here, and this looks like it's been rubbing, and the insulation is damaged and the conductor is exposed. I'm wondering if that might have been shorting out, if that was shorting out on here, because this is grounded. Alright, so this is 311. I cut off the exposed part of the, I cut off the section with the damaged insulation, and I heat shrunk the end of it, and I rerouted it out of the way so it can't rub up against anything over here. And I found out that 311 is mentioned in the wiring diagram. It has to do with these wires over here, 304 that comes in right here and splices to the 234s, has to do with the optional generator. So it says that in the case if you have an optional generator installed, you're supposed to disconnect one of these number 34 jumpers and attach it, I guess, to number 311 over here. So I think this is correctly hooked up right now. We just need to clean up this connection so it's not just flapping around here and able to short out against something. And I think that'll resolve that. 42 goes somewhere. I don't know where it goes. It just goes down to the plug, so I'm curious what that is, but I don't think I have to worry about it. And 409 goes to pin number 8 on plug BT4 on this board. So this is plug BT4, goes to pin 8, goes to something called RI20, which I think the I is for input because I see some ROs. I'm going to see if I can figure out what that is, because that wire doesn't seem to be going anywhere right now. Alright, I poked around on the wiring diagram looking at it on my desktop computer where I could blow it up more and really look at it really well to see if I could figure out some of these mystery wires. A couple of these wires have numbers on them that are so high they don't even appear anywhere on the diagram. So I'm not sure what the deal is with that. But they don't seem to be running anywhere, so I'm not worried about that. And then these wires over here, these that are tied together, these three, and I think it was this one. No, that's number 42. Didn't figure out what 42 is for. Can't find it anywhere. I think there was one of these was 311. 311 is used if you have the optional generator. So if you have the generator, you're supposed to install a toggle switch. I'm guessing maybe in this hole right here or one of these three holes, and it would basically you would flip the toggle switch depending on whether or not you were running off the generator or the diesel engine power. And to do that, these wires get hooked up a different way, and then 311, which is not currently used, would be used with the toggle switch. So I'm satisfied that I can just fix this wiring to tie these three together, and then these other ones that are either mystery ones or 311, I'm going to tie those off away from this so they can't get impinged by the mechanism here. So that leaves me with just focusing on this unit here. So this is the unit that actually is responsible for swing and for lifting and lowering the boom. And I know I've got a problem with that functionality, so maybe it has something to do with the fact that these wires are in really bad shape. There's also something screwy going on here. We've got a micro switch over here on the side that only has one wire going to it. So this micro switch does nothing right now, but I can see that one of the two connections of the micro switch still has a spade connector attached to it. So there was a wire going here at one point. What I'm seeing here with this electrical tape nonsense is three red wires being tied together. Furthermore, this micro switch on this side has three wires going to it, and the other interesting thing is the terminal strip right here, that is where the connections from this wiring harness connect to this whole mess. There is actually a wire connector right here that's got a jumper, but this connection right here on this side has nothing attached to it, which makes no sense at all. In other words, why bother having this wire come to this point if there's nothing attached to it here? And then the jumper wire goes over where it does have something attached to it there. So I think this is all screwed up wiring wise. So what I want to do is I'm going to disconnect these connections right here so I can take this unit out and just have it on the bench alone and focus on testing these micro switches and fixing up this wiring. Alright, I had to drill out one of the screws on this thing, but I did get it out, and no sooner did I get it out than I noticed this wire was disconnected from here. So these wires, these three wires here that were all kind of hastily spliced together and covered with this electrical tape, were barely held together. So that could be part of the problem also. So step one, I think I'm going to test these micro switches. Actually kind of hoping one of these micro switches is bad, because that would be like, oh, a real obvious fault that might have been what led to them kind of botching this wiring together the way they did. I blew up this section of the wiring diagram just so I could show you guys more clearly. This dotted line right here represents that everything inside this box is contained in this unit. And if we look at the circuit, it's very, very basic. It is pretty much identical to the boom, extend, and retract controller that I just repaired. The only difference is the boom, extend, retract was basically just one of these units, and the lever only moved like this, whereas this assembly allows you to have a joystick, so you can have two of these units controlled by one stick, whether you move it up and forward, forward and back, or left and right. But the point is that all they're doing is they're putting this digi-sensor device, which, as I mentioned, I still don't know exactly what this thing is. They're putting the digi-sensor in device with, in series with, a micro switch, and that's it. So you can see this actually says rotate control. So when you push the toggle switch forward or backwards, it will close this switch and connect the digi-sensor into the circuit. And then somehow this device is able to send a signal that will tell the system whether or not it's being rotated clockwise or counterclockwise. Pretty ingenious, I guess. Anyways, the point is, if we look over here, this is the lift controller. So this would be boom up, boom down. And it's the same thing. It's in series. This digi-sensor is in series with the micro switch. When we push that toggle switch, when we push that joystick, we're going to actually close the switch and put this in circuit, and voila. Couple of things to note. All four of these wires coming out of these two units seem to be independent wires. 103, 104, 105, 106. That's a little different than what I'm seeing in my circuit in real life here. But the bigger problem is, notice the micro switches only have two connections, because they're only using the switch for the normally closed position. Normally open position, meaning that this switch is open until you press down on the switch, which is done by the cam on the joystick. That's all it does. So there should only be two wires going to each one of these switches. But that's not what we have here. First problem is we have this switch only has one wire going to it. We know that's wrong because this does absolutely nothing. So there must have been, and since this is the common tab, something has to connect to here that has been removed. More troubling is over here on this switch. On this switch, we have three wires going to it. So this switch is almost acting as if like they're using the normally open and normally closed contact in this switch, which is not what this circuit requires. So why they did this, I have no idea. To make this even a deeper mystery, these connections actually go right into the terminals in there. So they had to have removed the terminal, the little connector from inside this plastic piece right here for probably this one. Which one is it? Let's see. No, the bottom one here. This bottom one right here. And that must have went somewhere else. And then, so they get this, the way this is all tied together, if I drew a schematic diagram of this, it would look completely crazy compared to what I've got here. Now, first I thought, well, maybe this is a different version of a circuit than what I've got. But then the more I thought about it, I realized, no, I don't think so. I think what's going on here is that somebody was in here monkeying around with this thing, and for some reason just decided to hook things up the way they did. I think they just completely muffed it up. There is one circuit change that I'm a little concerned about, which is I noticed that when remember when I just disconnected these wires from these screw terminals here on this thing, there were 5 wires because there was a ground wire over here. But then there were 4 wires, but 2 of these wires had they were tied together. So instead of having 4 independent wires going into this unit, I only have 3 independent wires with a jumper loop to create that 4th connection. If 2 of these wires end up eventually terminating in the same location, I guess it doesn't matter. But it's interesting that they don't show it that way. All right, so I've got this one all wired up, and I've got heat shrink tubing on the splices and the damaged areas on the wire. So now I've got to do the other side. Interesting little note. This is the switch that had the extra connection going to it that it shouldn't have had, which was this. Which, this being a red wire with a black stripe, tells me this is the original wire, but it shouldn't have been going to this switch. And the way I know that for sure now is this actually pulled out pretty easily, because this is a regular spade type connector that was not locked into this plastic connector. So when I pull this plastic connector off, these are supposed to come with it because they're locked in here. They're a different style. So this is something somebody just added, and they just stuffed it in here like this and pushed it on. I mean, it probably would have worked perfectly fine, but it's not connected to the right switch. So where it does need to go is it needs to go in here, but there's already one in here. So my theory is that the wire pulled out of here, and whoever was working on it put this connector on and put it onto there, or into here. Anyways, so in order to use this in this connector, I've got to get this old one out. Looks like it's the style that if you just push up on the little tab, it should unlock it and allow it to be pushed out the back. Yeah, I just need a much smaller screwdriver. So I'm just inserting the small blade screwdriver in there where the little tab is to keep it depressed, and then if the wire was still attached, I would be able to probably gently pull on the wire and pull it right out. But since that's not the case, I'm going to try and grab it. Yeah, so much for that idea. There we go. Took a little bit of doing. So you can see this is a completely different type of connector. This has got this little metal tab that I have now squashed down. And I got that tab pop back up. So if I were to reinsert this in there, it would click in and not be able to come out. All right, so I've finished rewiring this thing, and it's now wired the same way it's shown on the schematic. So we'll see what's going to happen. I decided just for giggles to hook my ohm meter up to this thing again and see whether or not I get any action out of it, because you know, originally I thought these were just potentiometers, which would have made life so much easier. But it turns out they are something else altogether. Still don't know what a digi sensor is. But I've got my meter hooked up now and set to the 20 megohm scale, which is the highest resistance scale. And when I flip the toggle switch and it closes the switch, nothing happens. Which is exactly what was happening on the other unit that I had out. So whatever these things are, they're not potentiometers. Just for the heck of it, I'll reverse polarity. I just flip the lead, so I'm reversing polarity on the meter to see if that makes a difference. It does not. I didn't think it would, but figured what the heck. So, interesting little devices here. They end up being in series with the rest of the circuit. So I wonder whether or not there are digital pulses being sent to this digi sensor, and if when you actuate this thing, does the digi sensor, depending on what position it's in, somehow change the pulse? I know it's kind of a stretch, but I mean, I'm just thinking outside the box here because I'm just kind of flummoxed by whatever this thing is. For all I know, this might be a more common device in industrial applications, but it sure doesn't appear to be. So I'm going to do one last thing to this unit before I put it back in. I'm going to kind of dress these wires with some wire ties in a way so that basically what I want is I want to make sure that these wires can't somehow get pushed back up where they end up impinging on this gear. Based on the damage that I saw on some of this wiring, it almost looks to me as if like at some point it was accidentally pinched in between this sector gear and this pinion gear.
All right, I'm almost ready to put this back together. I put this switch in, and now I just undid the 2 screws so I could move this this assembly right here, which is for the drive assembly to actually drive the unit. Now, I am able to drive the unit, but I did notice that I was having a problem where it seemed like sometimes it would throttle up when I would go to drive and sometimes it wouldn't, and I wasn't quite sure what was going on there. Well, on this assembly, there is basically on the top of the controller, there's a pivot rocker switch, which is for steering. That's just a simple switch. So there's 3 wires right here that go up to that switch. So that's working perfectly fine, and there's nothing mysterious about how that works. The drive forward and drive back, it works just like the boom extend or the other things here. It's got one of these digi sensors right here that's in series with a micro switch right here. So when you go to push forward, it closes the micro switch and puts the digi sensor in circuit, and the digi sensor moves clockwise or whatever for one direction and counterclockwise for the other direction. But unlike the other units, this one has this extra switch right here, this micro switch, which I just disconnected. These 2 wires right here actually go down to the system, and they're attached to this micro switch that gets closed anytime that this control is moved forward or backwards. And what this switch does, according to the schematic diagram, is this is the throttle up. So when this switch closes, it should send the signal to tell the engine to throttle up because you want to move. So apparently it needs a lot more power to drive all the hydraulic motors involved with moving the unit. So since I was having an intermittent problem with that, I figured I'd check this switch, and lo and behold, when I go across this switch and check the resistance, lo and behold, when I went across this switch to check the resistance and I activate it, I get 36 ohms. And it's not a bad connection on my meter, because when I close the leads on my meter, you can see that I'm getting a good connection. But watch what happens when I go across the switch. I'm going to close the switch. About 34.8 ohms. It goes a little higher even. So the contacts in that switch aren't very good. And that may very well be exactly why I'm having this kind of intermittent where it goes high in RPM. Because it might be just on the threshold of being enough to trigger the circuit that controls the engine. Well, I didn't have another one of these micro switches in stock, so I did order a couple off of eBay just to have for spares. But in the meantime, while I'm waiting for those to come in, I want to put this thing back together and test it. So what I did was there's this little slot on top of this case right underneath this leaf here. I was able to sneak the straw from the can of deoxit in there and squirt a little bit of deoxit contact cleaner in there. And now the switch appears to be working. So there was just oxidation probably inside there. So I don't know how long that's going to hold up. Like I said, I ordered another one, but I'll just leave this in there until it doesn't work. That's, of course, assuming that was even my problem as far as accelerating goes. Well, so one of the first things I found wrong was this capacitor was rolling around on the inside of the box when I opened it up. And this capacitor is just across one of the 2 sirens that are in there. Shut up. Anyways, but I'm still going to replace it. This is a 2200 microfarad at 35 working volt cap. I didn't have any new ones of these, so I went through my junk pile of
PC boards and TV chassis and stuff that I keep for parts. And I pulled out this one, same rating. I'm just gonna check real quick. I've got my handy dandy, quiet, my handy dandy EDS brand tester. I love this thing. I've got much more sophisticated and expensive testers than this one, but this thing's just so handy and quick. And let's just see what happens if I go on here. So it's testing, and we can see that the ESR is just on the very verge. When high capacitance like this, ESR is a lot more tolerated. So, and now actually it's now gone full up to the green. So DCR is normal. That's mainly all we really care about with. Typically, if you're going to have a failure with a capacitor, it's typically going to be leakage related and ESR related. So, anywho, this appears to be a good cap. I'm just curious whether or not this old cap, I think the only reason this failed was because I think the leads got fatigued or corroded and broke off. So I might be able to get these probes in there just enough to actually get a test off of this thing. Oh, look at that. And this actually is still a good cap, but we have no way to electrically attach it any longer to the circuit. So that'll go in the garbage, and we'll put this one in. I'll test the other one that's in there, make sure it's still good. And then I've got one screw that fell out. It was really loose on one of the warning lights. And I'm going to replace that screw and make sure I clean out the rest of that sawdust. And then we'll put this thing in the machine and see what happens. All right, I wired in the replacement capacitor, and I heat shrunk the leads to keep them protected. And I tested this one that's still in here, and it tests perfectly fine, so I'm going to leave that be for now. Then I spotted something else I didn't like. Looking over at this Superflex bus board, which is what they're calling, OEM Controls calls this thing right here, I spotted this capacitor right here, and it looks to me like it's slightly domed. In other words, it might be swollen, which could be an indication that it has failed or is failing. So I think what I'm going to do at the very minimum, I'm going to test that capacitor. And if I have one that size, I'm just going to replace it. I think that's the only electrolytic in the whole thing here. So, and that being said, why not? But what concerns me more is something I didn't notice until just now. You see this right here? This is a an interface. It's a programming port. And basically it's like a RJ11, I think, plug or socket. Well, there's one in here now, and I think the only purpose of this thing is probably to keep that socket clean so debris doesn't fall down inside there. But just for the heck of it, I took it out, and the horror is revealed. Besides there being like bits of this sawdust and stuff that I'm finding in here all over this thing, is down in there, it looks horrible. So you can see that bluish greenish color down there. That's all corrosion. So there's a bunch of debris and corrosion down inside that socket. But I'm really not sure what I can do about that other than just giving it a quick cleaning, because it's down inside there, it's hard to get to. So I just loosened the screws that allow me to take this whole board out, and found this rusty screw rolling around inside there. So it's another good reason I took this out, because that screw could have rolled around and gotten into something more critical, shorted something out. All right, I didn't end up showing the rest of the reassembly of the control box down in the basement shop, but all I ended up doing was cleaning out all that sawdust. I did clean that network connector and clean the plug that was in it, put the plug back in. I didn't end up changing that capacitor that I was concerned about, because it turns out that entire board on the top and the bottom is layered in silicone to protect it. So I did scrape off enough of the silicone to get to the bottom two contacts on that capacitor so I could do an in-circuit test on the capacitor. It passed ESR in circuit, so I'm just going to roll with that. I don't think that was currently one of my problems anyways, so we'll see. The only other thing I did besides clean it up was I found that this bulb right here, which is the oil, looks like oil temperature bulb. I don't know if that's for the hydraulic fluid temperature or if that's for the engine oil, but this warning bulb was burnt out, so I put a new bulb in there, and I checked these two and they're good. I just mounted the box back on the frame here. Last thing I got left to do before I try this thing is I got to reconnect this connector. All right. Hook back up. It turned a little bit cold, so hopefully this thing will start. I don't know if this thing's got a preheater on it or not for the diesel. So if it starts up, the first thing I'm going to do is I'm going to test the functionality from the base again, just to make sure that that hasn't changed, that it still works from the base controls. And then we'll try the newly improved basket station controls. And I do think this does have a preheater for the diesel engine, but I don't know if it works. Check the basket swivel comes through. So I'll put this key has to be on. Alright, let's see if it goes up. Oh, I'm not stepping on the foot switch. Oh, got something. As before, it won't go down. Turns very slowly. Won't turn right at all. Let's see if the boom extends. I fixed something. At least the boom extends now. Let's see if it retracts. It does. And when I take my foot off of the dead man pedal, it idles down. That's a good sign. And it does nothing. Boom won't extend when I'm not touching the pedal. up the idle more, but it doesn't move. Wheel steer. I wonder if this has to be back over before it'll I wonder if it has to be back lined up before it'll move. We go to the ground controls to get it back over to lined up. Alright, let's see, maybe the boom needs to be fully retracted. Let's see if that does it. Oh, alright. Try the speed switch, low to high. Maybe it's too low. Make sure that it goes back down first. Of course it doesn't. Now it does. There we go. I think if it's too low, it won't move. High speed. I don't think I'm going to fit underneath these branches on this tree. That's the problem with having such a big machine like this. Alright, I'm going to move this closer to the house so I can do some more diagnostics on it.